In this video, we are going to do these 7 questions from the chapter Relation and Function. While including these 4 MCQ, I can see that this is MCQ, this 2, 3, 4 MCQ. So let's start with the first question. The next question is an MCQ. Says what type of relation is less than, right? And in a set of real number. So what we can see, like say, if I check for the reflexivity, that means figuring out whether it's a reflexive or not. You know that for a relation to be reflexive, let's say if I say that A belongs to R, then A should be less than A. And this is incorrect. Reason being because if I take a number 2, it is equal to 2 and it cannot be equal to 2, less than 2. So it is not reflexive. Now checking for whether it's a symmetric or not. In case of symmetric, if I let's say take A and B are two numbers that belongs to R such that A is less than B, then B will be greater than A and it cannot be less than A. So this is wrong. That's why it's not symmetric. Now to check whether it is transitive or not, in case of transitive, what we can do, we are going to take three numbers. So let's say A, not three numbers, these are three elements that belongs to R, and such that A is less than B, right? And B is less than C, right? So from here you can figure out that A is the smallest and C is the largest over here. So clearly A will be less than C as well. So we'll say that it is transitive. So as for the option, we can say only transitive is correct in this case. The next question over here is if A and B are two equivalence relation defined on set C. Well, C is a set over here, but A and B are not set. They are they are equivalence relations. Now for that you have to remember that A intersection B will also be an equivalence relation. So let me justify why I'm saying so. Let's say if I make a set C over here, this is set C over here, and two equivalence relation, let's say the first as this and the second equivalence relation, if I take, say, this is the other equivalence relation, that is, say, this is A, this is B, and C. Make sure you remember that we are talking about A and B as relations. Now, clearly, this is what the A intersection B. Now, figure out why I say that A intersection B will be equivalence relation. So for example, if I take, let's say this is set, there is an ordered pair AA that belongs to set C. Since A is what is an equivalence relation, can we say that AA will belong to the relation A? And B is also an equivalence relation, so AA will also belong to the relation B. And since AA belongs to both A and B, we can say that A belongs to the element AA must belong to A intersection B. Now, this is the reason why it is reflexive. Now, if I check for symmetric, what I can say that I took AB and BC are two ordered pair that belongs to this universal set over here, say C in this case. As you can see that A is reflexive relation, so AB as well as not BC, sorry, it should be BA, right? We are doing with symmetric. So BA must belongs to the relation A. Reason why, once again, because A is a reflexive, right? A is reflexive over here. Now, B is also reflexive, then if BA belongs to the relation B, what I'm doing. It should be, yeah, AB belongs to relation B, then BA should also belongs to relation B. Again, for the same reason that it is a equivalence relation, right? Now, so we can say that if AB and BA both belongs to A as well as B, so we can say that AB and BA must belongs to A intersection B. The last one, for transitivity. So if I take, say, A, B, C are three elements that belongs to set C, such that AB, BA, oh, sorry, BC, right? We are looking for transitivity, and AC belongs to set, or not set, relation A. And since reason over here, once again, because A is equivalence relation. Since B is also equivalence relation, therefore AB, comma BC, comma AC, they will all belong to set B. And as you can see from here, that if these three ordered pair belongs to both A and C, it must belongs to their intersection. These must belongs to their intersection. And that's why we say that it is an, their intersection will be an equivalence relation. Now in this question, we are given set A with elements 1, 2, 3, set B with element 4, 5, 6, and the definition of the function. Like the function here is in the ordered form, it's f. That's 1, 4, 2, 5, and 3, 6. Now we have to check whether this function from A to B, whether it's a 1, 1 or not. Just 1, 1. We don't have to check for onto. Now, what do we, when do we say that a function is 1, 1? When we see the definition of the function, it says a function is 1, 1, also known as injective, from A to B is said to be 1, 1 if the images of the distinct element of x under f are distinct. That means here f1 is what? Placing x as 1, we are getting y as 4, f2, it gives 5, f3 is 6. You may also use arrow diagram, like if I take set A as this, 1, 2, 3, and the set B as these 4, 5, 6, 7. And if I try making the image over here with an arrow diagram, this 1 is 1 with 5, 4, 2 with 5, and 3 with 6. So clearly they are forming a distinct image. So it can be seen easily that the images of distinct element of A under F are distinct. So it is 1, 1. We are not asked for onto, but in case of onto, we should say that not onto, because here the element 7, which belongs to the set B, is not an image of any element of set A. So it is not onto, and that's an extra. As for this question, we just have to find whether it's a 1, 1 or not. So we'll say yes, it is 1, 1. The next question, he says R is a relation on the set N, where N stands for natural number by default, defined by Rxy such that 2x minus y equals 10. And we have to check whether these relations are reflexive, symmetric, transitive, or none of these. So what we can do, we can begin with reflexive. So I can do what? I can, let's say we know a number 20 that belongs to the set N. Now replacing x with 20, let's say if I replace here x with 20, 2 into 20 minus 10 is equal to y, right? Transposing these. So it is what? 40 minus 10 is what? 30, right? So this is y is equal to 30. So we can say that, what we can say that 20 comma 20 does not belongs to R. As you can say, replacing x with 20, we should get y as 20 if it is reflexive. But as you can say that 20 comma 20 does not belongs to R, so it's not reflexive. Now coming to the symmetric. Now placing x as 20, what we are getting y as, what we got y we got 30. So we can say that 20, 30 belongs to R, right? We have already got this. Now check, does 30 comma 20 belongs to R is what we have to check. Now replacing x with, or say y with 20. Over here, if I replace y with 20, so 2x minus 20 is equal to 10. So 2x comes out to be 30 and x comes out to be 15. That's not correct. So we'll say that 20 comma 30 belongs to R, but 30 comma 20 does not belongs to R. So it is not symmetric. Now same I can do with transitive. So we got, let's say, if I take 20 comma 30, as you know, belongs to R, right? And 30 comma what, like AB belongs to R, then we need to take BC also. Placing X as 30, right? We got Y as what? We got Y as placing X as 30. I need to check, right? So not check, we have to find out. If I place X as 30, so placing X as 30, and it should be what? Minus 10 equals Y, so it is coming 50, right? So what we can see that 30, 20, 30 belongs to R, and 30, 50 also belongs to R. So now we have to check, is 20, 50 belongs to R or not. That is whether AC belongs to R or not is our question. Now check again. If I place, that means we need to figure out that on placing X as 20, are we getting Y as 50? Well, this is not true because we have already done on placing X as 20, we got Y as 15, right? So therefore, this is also not correct. So it is, we can say it is not transitive as well. So the correct answer should be none of these, right? It is neither reflexive, not transitive, nor symmetric. The next question, which is an MCQ, it says find the domain of this function under root cos x. Now we should begin with cos x only, right? What we know about cos x, that it values, I'm not talking about the domain, right? Domain is x over here. I'm talking about cos x. The value of cos x varies from -1 to 1. That means we know that, let's say this is -1, say 0 and 1. So this is what the value of cos x varies from. But then you have to check here that cos here is an under root function inside an under root. Therefore, cos x has to be greater than equal to 0. As you know that under root of negative number are not real. So we need to modify this. That means in this case, the cos has to be from cos x has to be 0 to 1. So if I write that cos x has to be between 0 to 1 inclusive. Now for this to happen, that means cos being positive, what we know that for cos to be positive, right, what we know in this here, this is cos is positive over here and here, that is in the first and fourth quadrant. So this is 0, this is pi by 2, this is pi, and this is 3 pi by 2. So that means it is from this to this and also from this to this. So that is 0 to 2 pi and 3 pi by 2 to this is 2 pi as well, right? As you know, it's 0, 2 pi, 4 pi, and so on. So when I check the answer, I can say D is correct. It is 0 to 2 pi union 3 pi by 2 to 2 pi. So this is what should be the answer. In this question, it says state the reason for the relation R in the set 1, 2, 3 given by R equals 1, 2, 2, 1 is not transitive. Now, what we know for any relation to be called transitive is like if AB belongs to R and this is if AB, no, this is transitive. So AB belongs to R and BC belongs to R implies AC belongs to R. Now what you can see over here, 1, 2 belongs to R and BC, right? I'm considering now as B and C as this belongs to R, then AC will be what? These two will be AC. One more time, AB belongs to R, taking this as A, this as B, B, and this time taking A as C. Therefore, in order for AC belongs to R, 1, 1 must belongs to R. But over here, you can see that there is no AC. That means there is no 1, 1 belongs to R. So you can say that, but in case if AC does not belongs to R, So we say it is not transitive. Therefore, R is not transitive. This is what we have to write. So in this question it says that R be the relation defined on set of natural numbers, and this is what relation between x and y, where x and y both belongs to natural number. Further, we have to find out the domain, range, and we also need to check whether the relation is equivalence or not. So what we are going to do here is to first find the relation here, and here we are going to write the ordered pair. So first we are going to replace, let's say if I replace x with 1, what we are getting y as 22. Placing x as 2, we are going to get as y as 20. So let's write down the relation here in the ordered form. So it's 122, replacing x with 2, y comes out to be. Now we can place up to 11, because the moment if I replace x, in case if I replace x with 12, right, what we are going to get? We are getting y as 0, and 0 does not belongs to natural number. So this is what the relation we got. Now check in the next part, we got the relation and then we have to find the domain and range. So what are domain? These are the set of first number in the ordered pair is what the domain. So we got these domain as these numbers. Range over here, these are the range, the set of second numbers. These are going to be our range. So yeah, these are our range. So if I write down the range over here, so you know that a relation is equivalence if it is both, oh sorry, not only both, it's reflexive, symmetric, and transitive. So I can see that, let's say 220 belongs to R, right? I can write that 2 comma 20 belongs to R, but 20 comma 2 does not belongs to R. So we can say it is not symmetric. And since it is not symmetric, therefore it will not be an equivalence, because for a relation to be equivalence, it has to be reflexive, symmetric, as well as transitive. If any of these relation, that is either reflexive, symmetric, or transitive, is not there or is not satisfied, then we say that it is not an equivalence relation. And for that, we just need to give one example. It's not that we have to show that it is not reflexive, not symmetric, as well as not transitive.